So expression of two double integrations as a single integration. So sometimes the sum of two double integrations can be converted into a single double integral. And then evaluation of such type of integration is easy and also time saving. And it may happen that if we want to try to find out the double integration in two times, instead of finding the double integration two times, if we are able to find out, if you are able to convert that two double integration into one double integration, then definitely our work will be half. So how we will do this type of questions? So let us take one example. Express as a single integral and evaluate integration of dx dy under the limit 0 to 1 minus root of y to root of y plus integration of y dy with respect to y under the limit 1 to 3 and with respect to x under the limit minus 1 to 1. So now here we have given two integrals we have given. What is the integral? One is what? It is 0 to 1 and the limit of this is limit of x, sorry, limit of y because this is the function of y, so this is limit of x. So this first limit is limit for x and second limit is the limit for y. And now in the second part both the limits are constant. Both the limits are constant. There is no dependency over the limits. So what we have to do, either we have to first integrate the first part, this one, and we have to integrate this one, and then we are able to find out what is the, we have to add them and then we have the final answer. So instead of doing that, we are also able to convert this double integral into double, means two terms of double integral into one term of double integral. So how to convert it? Okay, so here the area of integration of first integration. So now let us see here, we have to first draw what is the area of integration of first integral as well as the second integral. So what is the area of integration of the first integral? Y equal to 0 to y equal to 1 and x is equal to minus y to x is equal to, sorry, minus of root y to x is equal to root y. So if we square it, what we are getting? X square is equal to y. So x square is equal to y is what? It is the parabola. It is the parabola. And similarly, the area of integration of second integration, it is, this is limit for y. It is already clear because we have to integrate with respect to y. So this is limit for y. So y is equal to 1 to y is equal to 3 and x is equal to minus 1 to x is equal to plus 1. Okay, let us see here what is the limit. What is this limits? First one is what? This is origin. This is the origin. This is point A11. This is point minus 11. And now this is the parabola. This is the parabola. What is the parabola? X square is equal to y. So if we see in this part here, this is x is equal to minus 1, limit for x, and x is equal to plus 1. This is the limit for x, minus 1 to plus 1. Next one, y equal to 0. Just look here, what is the limit of y? It is y equal to 0 to y equal to 1. So y equal to 0, this is y equal to 0 to y equal to 1. And if we go to the second integral, what is the limit of y? It is y equal to 1 to y equal to 3. So this is y equal to 1 to y equal to 3. Okay, and this is parabola x square equal to y. So one side, if we take the negative value, what is the x is equal to minus root of y and x is equal to this parabola from this part. From this to, if we take this part, it is what? Negative of root of y, and if we take this part, it is positive of root of y. So this is given. Okay, so now change of order of integration is what? Let us change over here. The limit of x is constant to constant. So what is the minimum value of x and what is this is the area of integration. X is equal to minus 1 to x is equal to plus 1. This is the area of integration for limit of x. So the limit of x varies from -1 to +1. And what about the value of y? So the value of y, what is the minimum value of y? It is according to this parabola. According to this parabola, so the value of y is what? What is the value of y over here? It is x square. So this is y is equal to x square. And what is the maximum value of y? The maximum value of y is y equal to 3. So that this whole part, this one is the area of integration. X is equal to -1, so 2x is equal to +1. X square is equal to y parabola to y is equal to 3. So this is the area of integration. So here the limit of x is equal to -1 to +1 and y is equal to x square to y is equal to 3. So this two terms of double integration can be written in this manner. How we can write it? 0 to 1 root of integration under the limit 0 to 1 minus root y to plus root y and plus 1 to 3 and minus 1 to 1 can be written as in this manner. So just look here, two terms of double integration is converted into single double integration. And now this is very simple to integrate it. What is the integration of dx? So we have to first integrate. So we have to first integrate with respect to, since this is limit for y, so we have to first integrate with respect to y. So x is equal to 1 to x is equal to -1, y varies from x squared to 3 dy and dx. So integration of y is equal to y, dy is equal to y. So y under the limit x squared to 3. If you substitute the limit, 3 minus x square, 3 minus x square, and limit of x is -1 to +1 with respect to dx. Again, if we again integrate it, what is the integration of 3? It is 3x, and integration of x square is x cubed by 3 under the limit -1 to +1. So if we simplify again, let us put the limit. So 3 minus 1 by 3 minus x is equal to -1, so -3, and -1 has to become plus 1 by 3. So we are getting, this is 9 minus 1 is 8 by 3. It is again minus plus 8 by 3. So 16 by 3 is the answer. So this is a very simple example of the conversion of two terms of double integration into single double integration. Okay, so I have taken only one example over here. So this is some another examples. Express the following double integration as a single term integration and evaluate this part. So again, just look here. This is the limit for x equal to 0 to x equal to y. Here is also the limit for x is equal to 0 to x is equal to 2 minus y. So clearly this is the limit for x, y equal to 0 to y equal to 1 and y equal to 1 to y equal to 2. Correct? So the total limit of y is from 0 to 2. 0 to 2, and limit of x is what? 0 to y and 0 to 2 minus y. So we can change it and we are able to simplify it. We get the answer. This is the answer 4 by 3. Similarly, this can be also changed. These two terms of double integration can be converted into single terms of the double integration. So everybody has to try to solve such examples. So there are 5 examples over here. Okay, so this is what it is, the part of the change of order of integration. That's why I have taken over here. Let me take some more examples. So I will go to the next part of this part.